slices the same data the other way. It shows the mix of journey purposes by mode. Read down the table following the arrows. So, for example, over half of all domestic air travel, 55%, is on business. Incidentally, this is a much higher proportion for business travel than you would find on international air journeys to and from the UK. For long-distance rail, VFR is the most common journey purpose, followed by business travel, but the others are also significant on rail. We see again how coach travel is dominated by holidays and leisure. And small though it is in total, as I've mentioned, more than half domestic air trips are for business and 1/4 for holidays. These are very diverse patterns of travel between the modes by journey purpose. So what are the key points from looking at the patterns of travel? First, 1/3 of all travel mileage in Britain is for journeys over 50 miles. The car dominates this, with nearly 80% of travel. Rail accounts for 12% and coach and air for the rest. The car dominates all journey purposes. Rail is relatively strong for long-distance commuting and VFR. Rail and air are both significant for business travel, and coach is significant only for holidays and leisure. Car travel seems to have flatlined in the last few years, while rail has continued to grow. And 70% of all long-distance travel is personal travel, holidays, leisure and VFR, with only 20% for business and 10% for long-distance commuting. Well, having looked at the patterns of travel, I want now to look at the drivers of long-distance travel. And I'm going to look at the effects on long-distance travel of incomes, cost or price of travel, and of travel time, how long journeys take. And I'm going to do that by each mode, as they all differ considerably. I'm also going to look at the effects of changes in the cost or the travel time of other modes. For the technical among you, these therefore are the own elasticities and the cross elasticities. This chart shows the effects of changes in income on the demand for travel by the 4 different modes and the 5 journey purposes. The more blobs, the bigger the effect. This tells us that rail travel is particularly income elastic for business and commuting, and air travel is income elastic for all journey purposes. But income has relatively little effect on coach travel and only moderate effects on longer distance car travel. So the strongly rising incomes over recent years from the mid-90s to 2008 have been very significant in growing long-distance rail travel and domestic air travel too. And of course both have been badly affected since the recession started. During periods of strong economic growth, different modes of travel experience very different patterns of growth and different patterns of retrenchment in a recession. What about the effect of price or cost? Now, you would expect the costs of travel to affect demand. In an urban setting, an elasticity of 0.3 is common. That is, a 10% change in price or cost gives rise to a 3% change in demand. But for long-distance travel, there's much more responsiveness to price. We'd call 0.3 pretty low. Only business travel has a similar elasticity. This slide shows that the cost of motoring has a moderate effect. Sorry, wrong slide. This slide shows that the cost of motoring has a moderate effect on car travel, as does the cost of coach travel. But for leisure journeys, rail is very price sensitive, with elasticities well over 1. So is air travel. And this helps to explain the success of the yield management strategies that the train companies and the airlines use to generate traffic and revenue. Now this is interesting. Travel time elasticities are pretty high across all surface modes, though not so much by air. So, worsening journey times, for example through congestion, will have a big impact on demand for long-distance car travel. Equally, speeding up rail and coach travel will have a major effect on increasing their demand. And the flatlining of car travel growth in recent years may well be due to increasing congestion on the road network and the perception of increased unreliability of journey times. By contrast, the improved reliability of rail services, higher frequencies, and some speeding up will all have helped to increase rail demand dramatically in the last 10 to 15 years, on top of the effect of rising incomes. I won't dwell on the effects of cost and travel times on other modes, the cross-elasticities. There is a simple result. Cross-elasticities are relatively low. That means that changes in cost or travel time on one mode affect the demand for that mode in the way we have seen, but promotes relatively little switching between modes. This gives an unexpected comparison with urban travel. So far, our elasticities of income, price, and time are much higher than you get for urban travel. But the opportunity to switch modes is much less than it is for urban travel. When you think about it, you can see why. For long-distance journeys, it suggests that people couple their choice of mode with their choice of destination. You would choose rail for a city break, and you would choose to travel by car for a country weekend. Now that doesn't mean we can never get people to transfer, e.g. from air to rail, because we know that happens on closely parallel and competitive corridors. But that is not the generality. There is one exception to this, and that is the effect of the worsening of travel times by car. These do generate shifts of demand, which are noticeable on rail and coach, but the reason for that is really just one of scale. I remind you that long-distance car travel is about 6 times the amount of rail travel, and 13 times the amount of coach travel. So quite a small switch out of cars will cause a big percentage jump in rail travel and an even bigger percentage jump in coach travel. For example, a 3% switch of long-distance car travel to rail would increase rail demand by 20%. So what does all this mean? First, for long-distance car travel, incomes have a moderate effect, as does the cost of motoring. Worsening of travel times does have a major effect on car travel and does divert demand to rail for business travel and to rail and coach for holidays. Car travel is no longer a luxury business. Rail is highly income elastic for business and commuting and strong for other journey purposes. This reflects how much rail has become a higher quality travel product in the last 15 years. Demand for personal travel, leisure, holidays and VFR is very price sensitive on rail, but switching to other modes is really quite modest. Coach travel remains largely unaffected by income growth. In spite of product improvement, it remains a relatively utilitarian product with connotations neither of luxury nor of being an inferior service. Almost exclusively used for leisure and holidays, it is price and time sensitive. Finally, air travel is the most income elastic, and price elasticity is also high for non-business travel. Overall, cross-elasticities are small compared with own elasticities. This means that there is little scope for promoting serious switching between modes for long-distance journeys. The only effect to note is that small switches out of car to rail create large proportionate effects on rail Finally, we're going to look at some scenarios for the future. For forecasting long-distance travel over the next 20 years, we first of all set a base case and then define some scenarios to test against it. The base case uses official government forecasts, economic and demographic, and also government forecasts of transport costs and of the transport networks. We then use our model to forecast long-distance travel over the next 20 years using these base case assumptions. And then we also try some different forecasts and scenarios and see what effect they have on long-distance travel. And we compare those with the base case forecasts.